This meeting is being recorded.
In Chapter 4, Problem 28, we're given, I believe there's 8 examples in the whole problem, but we're going to work through A through D here. And we're given these compounds, and we're asked to draw both of the chair conformations. So let's take a look here at structure A and see how we can accomplish this. So we're going to use these 2 chairs for A, then we can use these 2 for B, these 2 for C, and these 2 for D. So what I have are unsubstituted cyclohexane rings with the 2 conformations after chair flip. So let's start numbering some of these substituents, and our system does not have to follow IUPAC rules with our numbering as far as the lowest carbon group, etc. Because we're just using these numbers to generate our chair structures. So we will say then at carbon 1 in our first structure, we have a methyl group that is pointing up. So we'll call this our carbon 1, and we place a methyl group pointing up. So we'll indicate that's our methyl. And then right next door on carbon 2, we have an ethyl group that's pointing down. So we'll just use the abbreviations ME and ET to indicate our methyl and ethyl groups. And after ring flip, we see that we will still have a methyl group pointing up, but now in an equatorial position. And our ethyl group will still be pointing down in, again, an equatorial position. So something that looks like that. So we went from 2 axial positions to 2 equatorial positions, all of which, or I'm sorry, the 2 methyls will be pointing up and then the ethyl pointing down. And that we know from our wedge and dash. Our wedges we convention to point up, and then the dashes will point down. So let's take a look at B here. So we have both of our substituents on a wedge. So both of these will then be pointing up. We see carbon 1, carbon 2. So let's go to my first chair here. We have a methyl substituted carbon here pointing up. And then we also need an ethyl group to be pointing up as well. So we'll see that that one would be in an equatorial position here. So we have both pointing up, methyl and ethyl, one in axial, one in equatorial. And then after our ring flip, we'll see that our ethyl group would then be pointing up in an axial position, like so. And then our methyl group would be pointing up in an equatorial position, like this. All right, so let's take a look at what happens with the ring in part C. So we have, again, both on wedges. So we have a methyl group, we can say on our carbon 1, and then on carbon 3, we have a bromine. So both of these are pointing up. So let's go down to our structure in C, and we can say that on carbon 1, we have our methyl, and then on carbon 3, also pointing up, we have our bromine. These are both in axial positions. So we'll do our ring flip, and now in an equatorial position pointing up, I have my methyl, and then over here, we would have our bromine in an equatorial position pointing up. So after ring flip, both axial positions switch to equatorial, but again, they're still pointing up. In our last example, we have, again, both substituents pointing up. Now we have our bromine on carbon 1, and we'll say our methyl group is on carbon 3. So let's look at our chairs in section D down here. So we have on this carbon in the axial position pointing up, we have a bromine, and then we also have in the axial position pointing up a methyl group over here. And then after ring flip, we'll have an equatorial bromine here pointing up, and then we'll have a methyl, equatorial methyl pointing up on this carbon 3.